Okay, good afternoon, class. So at this point we're looking at the paper you guys have written last year, which was the November paper 1 of our school of 2022. Okay, so at this point we got up until the end of question 5. So now we're looking at question 6. Let me just get there we go. So we had the graphs now, question 6. So here we are told that the graph of f of x equals equals 3 to the minus x plus p, and g of x is equal to 3x minus 5 are drawn below. C is the point 2 and negative 2 and 10 as indicated there. A and B are y-intercepts. So it's going to make this a bit smaller so that we have some space here to the right. Okay. So the first question in the sum was 6.1.1. It says determine the value of P. So as you can see, there's one unknown in that equation, which is P. So I need one point on this graph, which I do have, which is C. So we're going to substitute C, which is negative 2 and 10, into f of x. You don't have to write this. So they're remembering that's the x and the y. So we have 10 is equal to 3 to the minus x. It's actually minus 2, as x is minus 2, plus p. So that's going to give you 3 squared plus p is 10, as negative times negative is positive. 3 squared is 9, 10 minus 9 is 1. So p is equal to 1. So instead of using p, I'm going to use the 1. Okay. The next question is 6.1.2. 6.1.2. We are told to determine the length of AB. Now in order to determine the length of AB, as you can see, A is your y-intercept of your exponential graph. So for y-intercept, what do? We let x equal to 0. Okay. So since it's on f, so f of 0 is equal to 3 to the negative 0 plus 1, which is 2. So the coordinates of A is 0 and 2. Then B, which is on the y-intercept of the straight line. So you say again y-intercept, we let x equal to 0. Okay. So you say g of 0 equals 3 times 0 minus 5. Give you an answer of negative 5. That's 0 and negative 5. So therefore the length of AB is equal to 2 minus 5, which is 7 units. Okay. That's going to give you an answer of 7 units. Alright, this is hope is not behind the calculator. Just to get away for a couple of seconds. Okay, nothing. Okay. Then the next question says, in 6.1.3, now in 6.1.3 we are told that determine the equation of H. Let's use another color here. So determine the equation of H if H is formed by reflecting the graph of G above the x-axis. So if something is reflected above the x-axis, what happens? The y becomes negative. Y becomes negative. So it's the graph of G. So the y becomes negative. So negative y is equal to 3x minus 5. So y is equal to minus 3x plus 5. So that's the graph if it's only reflected above the x-axis. Then we are told that then translated 2 units to the right. So it moves 2 units to the right, we subtract 2 on the x. So we shift 2 units to the right. Okay? Then x becomes x minus 2. Okay, it's the additive inverse of the x. So we take that from this point here. We have y is equal to negative 3 into x minus 2 plus 5, which is negative 3x plus 6 plus 5 is 11. And that is the graph of h of x. Okay. Give your answer in the form of y is equal to fx plus d. And there we go. That is in the standard form of a straight line. Okay. When we come to question 6.2. In question 6.2 we are given h of x equals 2x plus 1. Now this I made a mistake here. It should be h of x is equal to 2x minus 1. Okay. The question says determine the minimum distance between the points 10 and 2 and a point on h of x. So if you look at the h of x graph, if I draw what is given here, I draw this. It will cut your x-axis at a half. Okay? And your y-axis at negative 1. So that is your graph. Alright. Then if you look at 10 and 2, it's approximately here. Let's say it's there. The diagram not drawn to scale. So the question is determine the minimum distance between the graph, a point on this graph, and the point on h. And h is the graph, sorry. Okay. So that's basically what we're looking at. We're looking at the minimum distance there. Okay, now there's one of two ways of doing it. I've done both ways in the memo, where we worked with the perpendicular at the height there, we can work in the point of intersection of. But what I do was, I take that point into account. We know that that's going to be an x and a y normally, okay? But this y, in this case, since it's lying in the equation of h, that is y is equal to 2x minus 1. So that's we let that be 2x minus 1. So how do we work out the distance? We use distance formula. So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If this is x1, y1, this is of course x2, y2. So we got the square root. So it's going to be x minus 10 squared plus 2x minus 1 minus 2 squared. Which now gives me, I'm going to square that out, it gives you x squared minus 20x plus 100 plus, now of course that's going to give you minus 3, it's going to be 4x squared minus 6, so it's going to be 12x plus 9.
Mr. Bodin, I'm so sorry to interrupt you.
No problem.
How much did you say for the grade 8?
All the grade 8s are right.
All of them?
Yeah, so we
Thank
have...
you.
Okay. So that is... So it's going to be negative 32x, is that correct? Plus 109. So that is the algebraic expression for that distance between that point and a point on h. Okay. So since that models a parabola, and a positive parabola, which means to say the graph will have a minimum value. Can you see that? So I need to work out the turning point. Okay, so what do is I complete the square. So let's complete the square quickly. We got 5 into x squared minus 32 over 5